Okay guys, so hello, this is Rai Ahmed with you. In this video I'm going to compare two lenses, okay, having the same diameter and they have different thicknesses and they have also different focal lengths, okay, but you're gonna see how much you can extend the focal length in the same diameter, okay, and how important is the thickness of the lens, okay. And I don't know whether the thick one that I have, okay, is a doublet or a singlet. I'm gonna make it nearer, and if you know about these things, whether it's singlet or doublet, please tell me, okay. I'm not that expert in these terms, okay, in the meaning of these terms, okay, not I know what's a singlet and doublet, but I just don't know their physical meaning and physics, I mean, okay, the scientific meaning. Okay, and I know one thing which is I'm sure of, which is like when you talk about singlet lens is weaker than a doublet lens. Okay, so let's move on. They are on the table and we're going to put them on the ground. Okay, so here they are. Okay, we have the meter over here. We have the first lens, which is this one. This is, see how thick it is, very thin. Okay, and this is the lens, and here, okay, I'm just trying to show you its diameter. Let me take my time showing you it. So it's reaching 6 centimeters. Okay, it can reach the 6 centimeters, as you can see. Okay, now here I have the thick one, thick lens. I have with a bigger focal length, and here I have a laser beamer, which helps me in showing the locations of each focal length. And also I have here the battery, which turns on this, okay, and I have a pen just to mark on the ground where it where the focal length, I mean the focus, the focal point where it should be, okay, or where it is, okay. And also I have this is a card box for a medicine, but it's like the thickness here, okay, will help me put the lens like, and the light like this is the light, the beamer, there's a beamer over it, okay, it will increase its height, okay, and the lens, for example, will go like this, where I have one of the lights can go directly into the center of the circle of the lens, okay, because it's important, and because of the physical nature of the lens, as a rule of physics, the beam of light which goes into the center of the lens will pass through without any refraction, okay. Any parallel line to the line passing through, or any parallel lens, okay, sorry, any beam parallel to the center, to the axis of the lens, okay, which is the line or the beam that passes through the center of the lens, okay. So the axis is the axis of the lens, is where you put a line passing through the center of the lens, okay. And so those beams of light which are parallel to the axis, okay, will refract and they will intersect with the axis at the focal point of the lens, of any lens even. Okay, so let's start. Okay, here's our, just for your information. Okay, and you just watch me, okay, because my voice will be low, might be low as I record. Okay, so that's why I'm demonstrating this process this way with this introduction. So this is the lens. Okay, this is the thick lens with a big focal length. And if you want to tell me about doublet or singlet, there's a thin line inside it. Okay. So there's a thin line over here. And if you can see it, I can't see it. Okay, but there's a thin line in it, just a single thin line. Okay, so I think it's a doublet, it's not a singlet. Okay, anyway. So let's start. Okay. So I'm gonna put the beamer, the laser beamer, on the ground, and install the batteries for it. They are AAA batteries, as you can see, or as you saw. See, this is it. 3 beam lights. Those slits are the thing that will make the light, if you put it on the ground, make that thin line of laser. Okay. And here it has magnets, just in case if you want to put it on the board. They use it for demonstration in physics classroom, but to me it's a good tool to find the focal length at night, and we're currently at night as I record. So here I have those 3 lights. Okay, it's working. So as you see, the tiles have lines between them. Okay, so what I'm gonna do is just put the beamer just right in front of one of the borders between one of the borders of the tiles. Okay. I'm gonna put it over here. I'm gonna move the camera. Okay, and so just right over here. Okay, now we're gonna measure the focal length of the first one. Okay, and we have to put off the lights of the room so you can see the intersection of the lights, the 3 lights, 3 beams of light. So I have to put them parallel as much as I can. So you can see the light goes all the way there. Okay, so this is here. Our first lens, the thin one. This is the thin one. Okay. Okay. So to see the light has now intersected. So I'm gonna mark it with a pen. So we can see the first mark. Okay. Now I'm going to put the next one. This one is thick. See, as you can see, it's thick, so it's easy to be put standing, upstanding. Oh, sorry. Just first, I want to show you the position of the lens in front of the beamer. Okay. Now we're gonna shine the light and follow the intersection. Wow, very strong, very long. Strong to me, it means that you can make a very strong telescope with this thick lens. Okay, very strong. So we're gonna go and mark it. Almost. So yeah, now again give you an idea. So we're talking here, if you notice, let's go follow the marks. Okay. See, this is the first mark, this one, here, this is the first mark, and going all the way to the next mark. There it is, mate. Okay, here, see, look how much I moved. Here's the mark. Okay, here, under my feet. So this one, okay. You can see a red line there. Okay, so it's too long. Okay, and it comes like almost 150 because the thick one. Okay. gonna remove the thick one. I removed it. Okay, I removed the thick lens. And yeah, so each tile here we have on the ground, okay, is like 50 centimeters. So as you saw, okay, we had like, look with me, okay, this is the line where the mark is, okay. So if you count with me the number of tiles, okay, by counting the borders, so this is here, let's make it, so this is like the first line. See, this is a 50 centimeters each tile. So until the beamer we have like 1 tile, 2 tile, 3 tiles, yeah. So talking about 3 tiles, so talking about like 150 centimeters, so it's too strong, okay. This one, it couldn't reach the 40 centimeters or something like that, okay, the small thick one, okay. So yeah, 2 different diameters, no, I mean, sorry, the 2 different lenses of same diameter does not mean that you have the same focal length, okay. So I hope that you enjoyed this video, okay. Thanks for watching, guys. Please subscribe to my channel, and if you want something new, okay, some more experiments, please tell me about them, okay. Bye.